Section 7.4, Solving Trig Equations, Part 1. So we're going to start by reviewing our reference angle. Our reference angle is equal to the value that we find for our angle in quadrant 1. In quadrant 2, our reference angle, or the angle in quadrant 2 that we're trying to find, becomes from pi minus our initial value. In quadrant 3, we add that value to pi, and then in quadrant 4, we take 2 pi and we subtract that same value. Be sure that your calculator is in radian mode when finding your reference angles. Okay, so we're going to begin by solving, and we have to solve for x that's in between 0 and 2 pi. If it's on the unit circle, we have to give exact answers. Otherwise, we're going to round to 3 decimal places. So we first start by looking at this one, number 1, and knowing that it's going to be a calculator problem. And we know this because there's no value on the unit circle for x that we get 0.6 for sine. So we begin this process by saying, okay, well, 0.6 is positive, so where is sine positive? In quadrants 1, in quadrants 2. So we are going to find our reference angle by taking the inverse to find the angle x. And when we do this, we get about 0.643. So this is my reference angle, and it actually is one of the solutions for x because we needed an angle in quadrant 1. We're looking for angles in quadrant 1 and 2 that give us sine x of 0.6. And since we need quadrant 1, therefore our reference angle is one of the answers. So then our second answer is in quadrant 2. So this means our other x value comes from doing pi minus our reference angle, 0.643. And you plug that into the calculator and you get 2.499. And this is the solution that's in quadrant 2. And we're finished because there's only 2 values where sine is positive in quadrant 1 and quadrant 2. Now, for the next one, it says tangent x equals -1. Well, there's a angle on the unit circle where tangent is -1. So this is unit circle problem. And what that means is that we need to have exact answers. So where is tangent negative? Tangent is negative in quadrants 2 and 4. So the first thing we need to do is find our reference angle. So when you find the reference angle, you don't need to worry about the sign quite yet. The -1 will come into play when we find the x values in quadrant 2 and 4. So where's tangent 1 in quadrant 1? Pi over 4. So even though we found the reference angle, unlike the first problem we did, we're not going to use that as part of our answers because that gives us tangent that is +1. But we're going to use this and complete our little equations. Our first one is going to be in quadrant 2, so we do x minus pi over 4. That gives us 3 pi over 4. And then our other one is in quadrant 4, so we have 2 pi minus pi over 4. And this gives us 7 pi over 4. Okay, so in number 3, we have to do a little bit more work because we need to make sure that we isolate our trig function. And problems 1 and 2, they were already isolated, but now we have that plus 9 and then multiplying the times 4 in front. So we need to get rid of it. So my first step is to subtract 9. And then divide both sides by 4. So cosine is all by itself, so it is isolated. And then we should recognize right here that we have a unit circle problem. Because on the unit circle, there is an angle where cosine is -1/2. So which quadrants will cosine be negative? 2 and 3. So now we need to find the reference angle. And knowing your unit circle, you're looking at where is cosine 1/2 in quadrant 1? And that is pi over 3. So we need to use this reference angle then to find the x values, the angles that we're looking for in quadrants 2 and 3. So quadrants 2 is where we have pi and we subtract our reference angle and we get 2 pi over 3. And then quadrant 3 is where we add it to pi. And we get 4 pi over 3. In number 4, the first thing we need to do is subtract 1. 2 times cotangent of x equals -5, and now we're going to divide by 2. So we isolated cotangent, and it's equal to -5/2. So this is going to be a calculator problem. Because on the unit circle, cotangent is never -5 over 2. So to be able to use our inverse, we need to first change this to tangent. So that means tangent of x is equal to -2 over 5. So now we say, okay, where is tangent negative? Tangent is negative in quadrants 2 and 4. So let's first find the reference angle. So in your calculator, your reference angle equals tangent inverse of the absolute value of -2 over 5, because again, to find the reference angle, the sign doesn't matter. The sign is going to come into play by identifying the angle measure that's in quadrants 2 and 4. So when I do this in the calculator, I get 0.381. So this is my reference angle. Unfortunately, it's not one of our solutions, but we needed to find it to be able to find the two solutions we need in quadrants 2 and 4. In quadrants 2, we're going to take pi and we're going to subtract 0.381. And when we do this, we get about 2.761. And for quadrant 4, we do 2 pi minus 0.381, which gives us 5.902. So this one was quadrant 2, and this one was quadrant 4, and those are our two solutions. Number 5, we need to isolate the variable. So we're going to add 1. And then we're going to divide by root 3. So we get tangent x of 1 over root 3. So we know that we can't have a radical on the denominator, so we're going to have to rationalize it. The other thing to notice is that root 3 is a number that is on our unit circle, so maybe when we rationalize it, it is going to be a value on the unit circle or it might not be, but it's always good to rationalize it to see if it will be. So I'm going to take the square root of 3 times the square root of 3, and I get root 3 over 3. So this is a unit circle problem. Because tangent is root 3 over 3. So since it's positive, we're in quadrants 1 and 3. And then looking at your unit circle, you can find the reference angle. And you might have to do a little sine divided by cosine to figure this out. But at pi over 6 is when tangent is root 3 over 3. And since we need a solution in quadrant 1, my reference angle happens to also be a solution. So then to get our second one in quadrant 3, we're going to take pi and we're going to add pi over 6, which gives us 7 pi over 6, which is the solution that puts us in quadrant 3. In number 6, to isolate it, I'm going to add 4. And then I can divide both sides by 2 root 3. So I get secant x equals 2 over root 3, because I simplified 4 over 2. Now, just like we changed cotangent earlier, we're going to change secant into cosine. So cosine x equals root 3 over 2. So when you're given a secant, cotangent, or cosecant value, you don't need to rationalize that, because by me taking 1 over 2 over root 3, it undoes that. It rationalizes it for me, because I need cosine, which is root 3 over 2, which is rationalized and happens to be a unit circle value. And cosine is positive in quadrants 1 and 4. So in quadrant 1, if you look at your unit circle, our reference angle for where cosine is root 3 over 2, root 3 over 2 is pi over 6. And we need quadrant 1, so that's one answer. And then we do 2 pi minus pi over 6, and we get 11 pi over 6. And that gives us our quadrant 4 value. Okay, so in number 7, we need to isolate sine, and we can divide by 3 first. And I get sine x equals negative 0.5 over 3. So this is clearly a calculator problem. So so then we have to say, okay, well, sine is negative in 3 and 4. So my reference angle equals the inverse sine of positive 0.5 over 3. And when I plug this into my calculator, I get 0.167. Unfortunately, I don't need my reference angle as one of my solutions. But in quadrants 3, I'm going to do pi plus 0.167, which is equal to 3.309. And then in quadrant 4, I do 2 pi minus 0.167, which is 6.116. For number 8, we're going to add 9. and then divide by 13. And we have cosecant x equals 20 over 13. But we need to make it into sine. So we have sine x equals 13 over 20. So that's a positive value, and sine is positive in quadrants 1 and 2. And this is a calculator problem. So our reference angle is actually an angle that we need here, which is helpful. So we have sine inverse of 13 divided by 20, which is 0.708. So that's one of my solutions. And then my second one is going to be pi minus 0.708, which gives me 2.434. So all of these problems were in the linear format. It was just sine, cosine, tangent, cosecant, whatever. But now we have quadratic form, so cotangent squared, sine squared, cosecant squared. So we're going to follow the same steps. It's just going to be a little bit different. So we still need to isolate, but now we're going to isolate cotangent squared. So I'm going to subtract 5. And then divide by 3. So then I get cotangent squared, I forgot my x up there, of x equals 1/3. So we need cotangent, so we're going to take the square root. So that means that cotangent alone equals plus or minus the square root of 1/3. So we do need to rationalize this because the square root of 1 over the square root of 3, we can't have that root in the denominator. So this simplifies into this. So when we multiply by root 3 over root 3, we're left with root 3 oh, you know what? I don't need to rationalize it. Sorry about that. I don't need to rationalize it yet. I get plus or minus 1 over root 3, but I need it in terms of tangent. So tangent x equals plus or minus the square root of 3. So I don't actually have to rationalize. Sorry about that. So now we need to know the quadrants where tangent is either positive root 3 or negative root 3. And since it's positive and negative, that means that we can have positive and negative root 3 in all 4 quadrants. So now we're going to have 4 solutions. So our first step is to find the reference angle. This is a unit circle problem. So we just need to look at our unit circle. And in quadrant 1, tangent is positive root 3 at pi over 3. In quadrants 2, we're going to do pi minus pi over 3. Quadrant 3, we're going to do pi plus pi over 3. And in quadrant 4, we're going to do 2 pi minus pi over 3. Now, I didn't write the answers yet because what you can also do, if you haven't noticed, is just look at your unit circle. If it's a unit circle problem, there's no need to do this pi minus, pi plus, or 2 pi minus. You know that if you're going to use all 4 quadrants, even if you weren't using all 4 quadrants, if you know your reference angle, you can reflect on your unit circle and find the solutions that you need. So if I took pi over 3 and I reflected it into quadrant 2, that's 2 pi over 3. If I reflected that into quadrant 3, I'd get 4 pi over 3. And if I reflected it one more time into quadrant 4, I'd get 5 pi over 3. So I have 4 solutions, all because it was quadratic, and when we solve quadratics, we have to do plus or minus. So for number 10, we need to isolate sine squared by adding 3. And then dividing by 4. So this is going to be a calculator problem because there's no sine value for 3 over 4. Actually, you know, I believe we changed this I changed this problem in class and I made it a 5. So let's go back and do that. Because the square root of 3/4 actually will give you a unit circle value, and I don't want one. I want to do an example with the calculator. So, sorry about that. If I continue and I take the square root, I have sine x equals plus or minus the square root of 3 over 5. So because of this, I know it's a calculator problem. So to find, now you need to know, okay, well, where's sine positive and negative? Again, all 4 quadrants. So my reference angle is going to be the inverse of the square root of 3 over 5. And I don't need to rationalize it because it's not my final answer. And I already know that it's not on the unit circle. Rationalizing just helps us identify if it's on the unit circle or not. And I get 0.886. And this is my first solution in quadrant 1. And now to find the other 4, I have to do these little equations of pi minus 0.886. And you get 2.256 pi plus 0.886 gives you 4.028. And then 2 pi minus 0.886 gives you 5.397. So I have quadrants 1, 2, 3, and 4. So that's the difference between the linear and the quadratic forms of trig equations.